If anybody is hopping on now to the live stream, hi. We're going to get started in a couple minutes. I'm just getting everything set up, so just hang out. We'll get started in a few. And I'm sorry for the clicking noises. The light's bad. Okay, we're going to give everybody about 1 more minute and then we'll get started. Thank you for waiting if you guys were trying to be on earlier. And again, we'll get started in a couple. Okay, it's 8:30 everybody, so hi if you are on. Thank you for waiting. Tonight got a little hectic and I couldn't get home quite in time, but we are here now. So if you were here with us last night, welcome back. If you were not here with us last night, let me kind of explain to you how this is going to work. I have a couple things planned and we're going to go through those, and you guys are welcome to send me questions, to interact on the chat, or send me questions on Remind throughout that. I encourage you to do that. If there are things that we are not covering and you would like me to hit, please send them to me and I'm happy to do so. Briefly, I'm going to go over what I went through last night so that you guys can see. If you missed last night and you would like to participate, please just go back to the link on my teacher site. The full video is there. It's an 1.5-hour video that you can watch. You can even speed it up or do whatever you want to do. Hi, if you guys are just joining in. So last night, here's what we went through. Last night we went through angles and segments. We went through transformations and describing them, and we went through some basics of proofs. Tonight we're going to talk a little bit more about proofs. We're going to talk about constructions, and then I have sort of a hodgepodge of random things. But if you have other questions, please send them, okay? So last night, again, segments and angles, lots with parallel lines, isosceles triangles, and trapezoids. We went through the transformation rules. We went through some example problems. We went through actually doing some. And then we went through describing them, and we looked at some questions that would get full credit and some that wouldn't. And then the last thing we did was go through some proofs. So if these are topics that you're interested in, go back to last night's live stream. It's on my teacher site under Geo Midterm Review, and you guys can access that there. But tonight we're going to move on a little bit. So a couple things before we get started. This is the deal tonight. If you would like to participate, you have one of 2 options. If you have a YouTube account, you can participate in the chat, which should be right on the screen. I have posted there, send questions here or on Remind. If you are not a YouTube account holder, that's fine. Send me a message on Remind. If you're not one of my students and you would like to join a Remind to be able to just shoot me a message, this code right here will get you into my Remind. So just text GBG9D4. There's your code to 81010. We're going to give everybody about another minute to get in here and get started. If you guys can hear me okay, just either shoot me a message on Remind or type it in the chat so I know sound is working, and we will get started. And if you hear clicking, it's just me going back on Remind to make sure that I see any messages anybody sent me. So don't feel like that's weird. Nothing's wrong with your computer. Okay, I got a couple I can hear me's. And a couple people who were here last night, which is awesome. Okay, so we got about 25 people with us so far, which is great because I know people are still getting logged on. So, midterm format. We talked about this briefly last night. Your teachers probably talked to you about this, but you're going to have 10 multiple choice, 7 short answers, including a construction, 2 proofs, a similarity, and a congruence proof. So, make sure again that you're reading the questions. They may not just ask you to solve for X. Right? They may not just ask you to solve for X, okay? They might ask you to go beyond that. Also, make sure you're explaining why if you're asked to do so. And the expectation is, again, a thorough response. So make sure that you have that. Tonight, we're going to do a couple more proofs. We are going to talk about some constructions, and then we're going to do some mixed topics. If you have particular constructions that you would like to go over, please message those to me in the chat, okay? But I'm going to pick ones that I think would be helpful. So we're going to start with some proofs, and I have 2 here that are congruence proofs, and then 2 that are going to be some similarity proofs for us. So we're going to start with this one right here. So take a second and just take a look at this. I just got a couple questions that I want to make sure I address before we start. So take a look at this one. One good question, do all geometry classes take the same midterm? So you guys are all taking very, very similar midterms, but they are not necessarily all the same. Honors has a slightly different version than Lab and Regents. Lab and Regents, you guys have the same exact exam, but 95% of it is exactly the same. And all the honors will take the same test as all the other honors, and same with Regents. Okay, so let's get started on this proof. So again, always think about your given and then think about what you're trying to prove here. Is it congruence or is it similarity? So on this particular one, I'm given this symbol right here, and I need to remember that that means parallelogram, right? So there's a whole host of properties that come to mind when I think that. Properties like opposite sides congruent, opposite sides parallel, diagonals bisect each other, opposite angles congruent, right? All of those theorems that we learned. But I'm going to just keep that in the back of my mind. The most common theorem that we're going to use tonight is the fact that the sides are parallel, but any of those could be used. And then we're also given that HP is congruent to JQ. So HP is congruent to JQ. And actually, I wanted to change this a little bit. So I'm going to make this GP is congruent to IQ. Again, the other way you can do it, it involves segment addition. I don't want to start us off on a segment addition proof. We'll work our way out. So I'm going to mark first what I know, which is that this piece is congruent to this piece. And the only other thing I know is that it's a parallelogram. So think about what comes with that. Parallelogram, the first thing I hear is parallel. And when I see parallel, I'm going to think, okay, well, how could that help me? Typically, parallel helps me because I wind up with some type of angle pair. And I usually think of alternate interior first. So I'm going to think about the fact that if I know that GH is parallel to JI, then I would have this transversal right here. And that would give me a pair of alternate interior angles right there and right there. So I'm going to label those angle 1 and angle 2, and I'm going to use those in my proof. The other pretty obvious pair of angles that I see here to me are these ones at the point X, I see that we have a pair of vertical angles. So I'm going to mark that those are congruent. And then looking at what I have here, I see that I have multiple things marked. So I have this angle, right? I have this angle, and I have this side. And so now I have a theorem that will help me. My plan here is to use angle, angle, side. And if you guys are in my class, you know that I always have you write your plan over there so you can kind of check it off as you go. So we're going to start my proof. I'm going to start with statement and reason. As you guys know, every good proof starts with your given. And on the midterm, please make sure that you are copying your given out exactly. For the purpose of tonight's video and the fact that some of you guys have multiple midterms and we've got other stuff to get to, I'm not going to recopy it, but you should be doing that. Then I always look at my given and I say, okay, within my given, do I see any congruent statements? I see right here that I have a pair of segments that are marked congruent. So since my plan is angle, angle, side, one of those segments is already given to me. So I don't need to show that. Then I'm going to go to 2. Okay, so the next thing I had was that my angle 1 was congruent to angle 2. But before I can say that, I need to know that those sides are parallel. So I'm going to say here that GP must be parallel to JI, and I'm actually going to put GH because that's the whole side of the triangle, or of the parallelogram. So those sides are parallel. What's the reason that I know that? Well, I was given that it was a p-gram, right? And so what I can conclude from that is that my opposite sides are parallel. That allows me to use any angle pair with parallel lines to go from there. So step 3, then I can talk about angle 1 being congruent to angle 2. And my reason there being, okay, remember we want a full reason, a theorem, which is parallel lines cut by a transversal implies that alternate interior angles are congruent. Now, I just got a great question. The question was, how do I know that I need to put that parallel step in? So I want you guys to look here and at my reason there. It starts with the fact that I have parallel lines, right? But that is nowhere in my given. So in order to use the fact that I have parallel lines, I need that in my proof somewhere. And so think about the fact that these should connect. Here I see my sides are parallel. That connects to the fact that I have parallel lines. So remember when we talked about those DirecTV commercials where one thing connects to the next? That's what this is. This is a continuity piece. That in order to use the property that they're parallel, I need to state that somewhere previously. Okay. Now you could also here use these angles right here and say that those are alternate interior in the same step. And you would actually be done and use angle, side, angle. But I am going to use vertical angles just so we can see that diversity in reasons. So step 3, that gave me an angle pair. I'm going to cross out that angle in my plan. Now, step 4, I'm going to use these, and I'm going to label this with a 3 and a 4. Make sure if you're not labeling it with numbers that you're using all 3 letters to label that vertex because there are multiple angles at X. So step 4, I would say angle 3 is congruent to angle 4 because I have vertical angles and I know that they are congruent angles. Okay, vertical angles are congruent. So look up at my plan now. That was my other angle. All 3 of my parts of my plan are checked off. So what that allows me to say in my step 5 is that triangle GPX is congruent to triangle IQX. And I knew I was looking for congruent here because notice I'm showing segments are congruent. So that reason is my theorem, angle, angle, side. Okay, or angle, angle, side congruent to angle, angle, side implies triangles congruent. And step 6, that one step after my triangles are shown congruent, is that PX is congruent to QX. And what's my reason? Well, think about this fact, right? That I know the triangles are congruent. And so that means that the corresponding segments are congruent. I often see people who will forget this word, corresponding. Without that word, this theorem is not true. It's only corresponding segments that are congruent. So please make sure that's in there. Again, if you have questions, send them. I'm getting all of the ones you send, and I'm trying to work those into my explanations. So thank you for those of you that have sent them. If I don't see any other questions on this, I'm going to go to the next proof. But that does not mean that you can't still send me one. I can always go back. Okay? Okay, next one, and this one says challenge. Don't let that scare you. It's just the paper I took it from. Okay, so challenge here, ABCD is a parallelogram. So I'm going to trace over that. That's my parallelogram. So I'm already going to see some things here that might be useful to me. Parallel sides, right? Congruent sides, all sorts of things like that. I know that DE is perpendicular to AF. And CF is perpendicular to AF. Perpendicular should automatically pop into your mind right angles. Okay? So if DE is perpendicular to AF, then I know that those meet at right angles. And if CF is perpendicular to AF, then I know those meet at right angles. So I see that those are probably the two triangles I'm going to get congruent. I see I have an angle already. I want DE congruent to CF, so that's my plan. And here's what I know. ABCD is a parallelogram, so opposite sides must be congruent here. So I know the hypotenuse of each of my triangles are congruent. Now, this other part is tricky. Why do we need to know this? Well, parallelogram also means parallel lines to me. So here's what I want you guys to see. AD is parallel to BC. Hopefully we agree with that. They're opposite sides. They must be parallel. And so what I can see there is that angle A and angle CBF are actually corresponding angles. Think about your two parallel lines cut by a transversal. Corresponding angles are, I'm just going to erase that stray mark, like right here and right there. They're in the same location. And so both of these are located to the right of my parallel line and above line AF, that transversal. So my plan here is going to be angle, angle, side. And we're going to have to do a little bit of thinking to show this, but same plan. So statement, reason, again, make sure your given is in there, okay? And I'm going to start at step 2 because we know to copy our given. So let's start with the right angles. I'm given that we have a bunch of perpendicular lines. So I'm going to label this angle 1 and that angle 2. And I'm going to say that I know that angle 1 and angle 2 are right angles. Because remember, that's what perpendicular tells me. Okay? Because perpendicular implies right angles. There's nothing there about congruence, but perpendicular implies right angles. Then, once I know they're right angles, I can say, well, guess what? Those babies are congruent, right? Because I know that right angles must be congruent angles. Okay? And so I can cross out one angle because I've shown that in my plan. Let's go for our next angles. I use the fact that we had corresponding angles here to get this angle congruent to that angle. So before I can use the fact that we have corresponding angles, I have to say that AD is parallel to BC. And this goes back to Caroline's awesome question before, which was, how do I know to show that those are parallel? Well, I'm going to talk about parallel lines. And so I need to know that there are parallel lines. So this is a p-gram. And that implies that my opposite sides are parallel. Then here, I am going to say, okay, that means angle 3 is congruent to angle 4 because two parallel lines cut by a transversal implies that corresponding angles are congruent. And that is my second angle in my plan. So we're 2/3 of the way there. Step 6, I just need that side. So remember we said that side AD should be congruent to side BC because in a p-gram, we know that opposite sides are congruent. And that is the third part of my plan. Once every part of your plan is checked off, my step 7 here would be to say that my triangles DE is congruent to triangle BCF. And notice I want to name it in the same order. BCF. By angle, angle, side. Or angle, angle, side, congruent to angle, angle, side, implies triangles congruent. That is not what they asked me to prove. My actual proof statement was this baby right here. So now I can say with certainty that DE is congruent to CF because congruent triangles implies corresponding segments are congruent. Okay, so there are 2 congruence proofs. We're going to look at 2 similarity proofs, and then we're going to go into some constructions. Okay, so let's look at some of those. Again, feel free to send questions. We have way more people watching tonight. It's a little bit quieter. I think you guys have studied a little more, which is great, but please keep sending them. All right, so this next one, a big giveaway that this is a similarity proof. Guess what I see? A similarity symbol. So I want to show these are similar. Think through your similarity proofs. I know that I have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. We talked about those more last night. Now, on this particular one, I don't have any information given to me about the sides of these triangles. So my guess is I'm going to use angle-angle here. So I'm going to think through my statement reason, and let's do some marking first. Parallelogram makes me think automatically parallel sides. So let's think about how that might help us get some angles. If I say that this side is parallel to this side, then I have a lot of alternate interior angles. I know that this angle right here, DCF, is alternate interior to this angle here. I also know that this angle here is alternate interior to that angle there. Right? Look for that Z. And lastly, I know that I have a pair of vertical angles here. So we actually have a lot of options for which to use. On the last proof we did with vertical angles, I did 2 different reasons. So I'm going to show you guys how to kind of stack those reasons all into one step here. So I'm going to say step 1 is my given. Step 2, I'm going to use the fact that I have parallel sides. So I'm going to talk about alternate interior angles. That means I'm going to have parallel sides. So I'm going to say that DC must be parallel A because in a parallelogram, I know that opposite sides are parallel. And I just got a question about that, so I want to make sure I answer it. So how do we know the statement for parallelogram implies opposite sides parallel? Well, I know I'm going to be talking about an angle pair, right? And those angle pairs only are congruent when the lines are parallel. So this is a property of parallelograms. Since I know it's a parallelogram, my opposite sides must be parallel. That's how I know that I have to use it. If that didn't answer your question, try to rephrase it and send it to me in a different way because I'm not 100% sure if that answered what you were asking. Okay, so now I'm going to go through and put in my angles. And I'm going to call this 1 and that 2. I'm going to call this 3 and that 4. And I'm going to ignore the vertical angles for right now. You could use them if you wanted to, but I'm going to show you guys how to kind of stack your reasons here. So step 3, I'm going to say angle 1 is congruent to angle 2. And for the same reason, angle 3 is congruent to angle 4. So I'm combining those into one step. And so then I can say, well, I know the lines are parallel from my step 2. Parallel lines cut by a transversal implies that my alternate interior angles are congruent. Again, you could use vertical angles here, but I chose not to show you how to combine reasons there. So now my plan here is angle, angle. I showed both of those. So now I'm going to say that triangle BFE is similar to triangle CFD by angle, angle similarity. Or if you have corresponding angles congruent in two triangles, then those triangles are similar. Okay, we're going to do one last similarity proof. So looking at this one, they asked me to prove that this cross product is true. Okay? They asked me to prove that this cross product is true. And actually, I would like to white out what is currently here. And we're going to work backwards from this because I don't like that. Okay, so here's the deal with this. We are given this cross product. I want to figure out what in the world I'm trying to prove here. So I know when I have a cross product like this, that this must have come, sorry about that, Mark, from a proportion. Okay? So I'm going to set up a blank proportion. Blank equals blank. And I'm going to try to think about this backwards. If two things are being multiplied in a proportion, it means that they are across from each other. So I'm going to do AB diagonal from CE. And then I'm going to do the same for the other side. So AC diagonal from BD. Okay? So if I went back and cross-multiplied these, I would have AB times CE and AC times BD. What I wanted to prove. This shows me that I'm trying to get triangles similar because I see that I'm asking about proportionality. So what I'm going to do here is I'm going to look at what corresponding parts those are and try to figure out which triangles they go with. So AB is this piece, AC is this whole side. Those are corresponding sides, so that's a good start. BD is this bottom side, and CE is this bottom side. So those are corresponding parts. So what this tells me is that I want to show that this little triangle is similar to this big triangle. And I am not given any information about the sides, so I'm going to go for angles here. I'm given parallel lines. So statement and reason, let's start this out. Okay. I'm given parallel lines, so let's look for some angle pairs that might help us. I see that 1 and 2 and 3 and 4 are marked already, but I also know that when I like this, and they're cut by a transversal, angles like 1 and 2 are congruent because they are corresponding. Okay? They are corresponding. So I'm going to say that angle 1 is congruent to angle 2. And similarly, angle 3 is congruent to angle 4. Because I know when I have parallel lines cut by a transversal, implies corresponding angles are congruent. And guess what? My plane is angle, angle. I have both now. So that allows me to say that triangle BAD, and I know you guys can't see this right now, I'll scroll down in 1 second, is similar to triangle CAE because of angle, angle similarity. But we are far from done with this proof. So, far from done. Step 4. Next, I'm going to put my proportion. So I'm going to say that this statement right here, and I'm going to be a little lazy because I can be. Thank you, technology. I'm going to paste that right here. Okay, that's my proportion. The reason that I know that that is true is because when I have similar triangles, that implies that my corresponding sides are not congruent, right? They're in proportion. And if that's true, then guess what? My cross product is also true, which is AB times CE equals AC. Because, and remember we discussed this last night, so if you need a refresher on this, just go back to last night's video. The product of the means is equal to the product of the extremes. Right? That's our technical phrase for what you guys have always called cross multiplying. Okay, so I just got a great question. If I'm in honors, would I get the proportion that you erased? Will I have to make the proportion from the cross products given? I would totally expect that if you are in honors, you could make that proportion on your own from the cross product. Even in Regents, would that be difficult? Yeah, but I totally believe that that's something you guys could do. So expect that if you were given a cross product, you would need to be able to work backwards to the proportion. But just remember, they have to be diagonal from each other and work back from there. Great question. Okay, so I'm going to go to constructions, but please send me any last questions you have about proofs. One last thing I want you guys to know, if you go to my teacher site, whether you're in my class or not, and go to any of my geometry pages and click on Unit 3. I should have brought it up here. Maybe I'll try to at the end of the video. I have about 9 videos of just me going through proofs, just how to do them, thinking through them, talking out loud. So if that's something you want, feel free to watch those. Your test isn't till the afternoon tomorrow, so many of you have the morning to study. Feel free to do that, okay? All right, constructions. This is a site I'm going to refer you guys to, and I'm going to go to it so you can see it in a second, but just Google Math Open Reference and then constructions, and you're going to see the site that I'm going to right now, but that's going to be where I would start if you need a refresher on these. So I'm going to show you guys a couple constructions. I've had a couple requests, and I'm seeing a couple questions come through about proofs, so we will talk about those. So this is what the construction site looks like. We're going to get it to reload. And my internet is being slow. Okay. So lines, angles, segments, all sorts of different things here. Triangles, things we haven't even learned yet. But there's so many constructions here, and these go through step by step. If you're in my class, you've seen me use these. If you're in another class, you may not have. So this is something that we're going to go through. So a couple of requests that I've gotten, I had one for a perpendicular through a point, and another for parallel lines. So we're going to look at both of those quickly. So perpendicular through a point. So I'm going to go perpendicular under lines and through an external point. Let's start with that. So I'm going to click on that one. And here's what you would want to do. And again, please make sure you're bringing your ruler and your compass with you tomorrow. You're going to start with a line and a point off that line. And you're going to place your compass on that point. Open it just past the line. And then you're going to draw arcs that cut across both sides. So there's one and there's the other. And the beauty of this is that what this gives you are endpoints. So I now have these endpoints for a segment, and R is right in the middle of that. So then all we're going to do is we're going to bisect that segment. So put your compass on a point, open it more than halfway, draw an arc from both segments, or points, sorry, and then connect those. Okay? I did just get a question, are there going to be extra calculators or compasses? We do have some extra calculators. Please try to bring your own and make sure it's charged. We do have some extra compasses. If anyone has been in my classroom, you don't want to use my compasses, trust me. So try to bring your own if you have them. Okay, so I'm going to run this one more time, just so you guys can go through it. So place your compass, open it just beyond the line, swing an arc, and then bisect the segment that creates. Another request that I've gotten was for an altitude, and here's the great news. An altitude is just this construction. So I'm going to show you guys how. I'm going to go back to that other program, and then we'll come back to here. So, come on. By the way, if any of you have an iPad, Notability, I highly recommend. It is your friend, and then when it doesn't want to load, 9 Okay, so here's the deal with this. If I have an altitude, what that really is a line that is perpendicular to the base from that point. So what I would do is that same construction I just showed you. I would put my compass on this point. I would swing an arc that cuts through both, or the bottom line twice. Use these as my endpoints and bisect that, right? And I'm just sketching because there's no compass in this program. And then I would connect that down. So it's the same construction we just went through. Okay, let's go through a couple more that I saw that we had questions about. So I'm just going to hit the back button. Again, I'm sorry, it's a little laggy. The last one I saw was the, which one did we ask about? Wasn't these, oh, it was about copying an angle. That was it. And copying an angle also works to construct parallel lines, or you can translate to construct parallel lines. But this was another one that I saw. So you're going to start with an angle. You are going to take your straight edge, and at a new point, you're going to lay a new foundation. Draw a new ray. Okay? Then you are going to draw an arc that cuts through both sides of your current angle. Slide it to your new foundation and do the same thing. Then you're going to measure how far open your current angle is. You are going to slide that down and draw another arc. And that is your copied angle. Draw in your ray. So I'm going to run that one more time. Okay. We are going to lay our new foundation. Then we're going to draw an arc that opens through both sides of our current angle. We are going to do the same thing on our new foundation. Measure the distance that your arc is open and slide that over to your new point, drawing in a new ray. Again, all of these are available on this site. Okay, last one I just saw was bisecting an angle. And Meg, I saw what you asked about the reflection. I'm going to show you that in the other app because I don't have a good applet for that on this site. So bisecting an angle, I'm going to go to angle and go to bisect. And let's run this. We're going to start with an angle. We are going to create 2 points by drawing an arc that intersects both sides. Maybe. There we go. Okay. Then we are going to slide this up. Make sure it's open more than half the width of the angle. Draw an arc. Keep it open the same amount. Draw another arc. And then connect your vertex to that point. Now, I'm getting a lot of specific questions. Do we need to know how to do that? Do we need to know how to do that? Any construction is fair game. But I would say to you guys, focus on things that your teacher talked about in class as things that might be important. And don't spend 7 hours trying to study one particular construction. Make sure that you're spreading your study time out over a variety of things. Okay? All right, the last one that I saw a question about that I'm going to talk about is a reflection. So a reflection off the coordinate plane. So when this loads, we will do that. And then we're going to do a couple little miscellaneous things. And then I will let you guys go because I know it's late. I'm sorry that it's so late. All right. So Meg asked about a reflection off of a coordinate plane. So let's say I start with, I'm just going to do a segment to keep it simple. So I start with a segment. Okay, I have my two endpoints. And I want to reflect that over some given line. So I'm going to put a given line in here. And that's going to be what I want to reflect over. So what I would do is pick any 2 points on that line. I don't care where. Okay, they can be endpoints if it's a segment. And then I'm going to measure, and I'm going to show you guys this in dotted line, from that point to one particular point. And I'm going to swing that around to mark that distance on the other side. So kind of do an arc over here. Again, I'm doing this without a compass, so bear with me. Then I'm going to measure from the other point to that same point. And I'm going to swing an arc and put that over here. That point would be the image of this point. So if this is A, that would be A prime. Okay, same thing here. I'm going to measure from my first point to there. And then swing an arc over to here. And then measure from my first point to here. Swing an arc over to here. Boom. Whoops. And again, if those don't connect, use your compass to connect them. That would be, if this is B, that would be B prime. And then this would be the image after that reflection. Remember, it should be symmetric over the line of reflection. And you can even get really fancy and talk about how the line of reflection is the perpendicular bisector of segment AA prime, right? This should be perpendicular and should cut that in half. Okay, last couple little things. We're going to talk about dilating a line and perimeter and area of similar figures. These are common questions that I had from my own students, and so we're going to talk about these. So these two lines, these are dilated from each other. We took each of these points, we dilated it by a scale factor from a certain center, and I want you to think about what you notice. These lines, though their location changes, the slopes stay the same. They are parallel. When I dilate a line by something other than 1, the resulting image is going to be parallel, okay? That is just a fact of dilations here. So when I dilate a line, okay, the slope will stay the same, but the y-intercept will change. So I'm going to show you guys what I mean by here on this one. Remember that this is my slope and this is my y-intercept. Okay, so here's what we're going to think about. Let's say I want to dilate this by a scale factor of 10. So I want to get 10 times as far away from a center and 10 times the magnitude of, a segment, if that's what we were discussing. So y equals 3x plus 4. My slope is going to stay consistent because it's a ratio, and the ratio will change consistently. So this is going to stay 3. That's going to be an x. My y-intercept, which is a point, is going to dilate by my scale factor. So if my center is 0, 0, it's going to just multiply by a factor of 10. So this would be the image after a dilation. Very, very similar with this one, except this is not currently in y equals mx plus b form. So I'm going to solve this for y. So add 2x to both sides. So y equals 2x plus 31. And let's dilate this by a scale factor of 1/2. So I would have y equals, remember your slope will not change, plus 31 divided by 2, which is 15.5. So this would be my image after a scale factor of 1/2. So remember, your slope stays the same, your y-intercept changes. Okay, last thing, and then you guys can fire questions away. Perimeter and area of similar figures. So this was a lesson from our Unit 5. We talked about the fact that the ratio of the sides, which I'll say here is A over B, is the same as the ratio of our perimeters. So if my side length doubles, my perimeter doubles. Okay, that is a direct relationship. But it is not the same as the ratio of the areas. If you have the ratio of the sides, to get the ratio of the areas, you would square those. So here's what I'm going to do. Let's look at a couple examples. So this one gives me 2 side lengths, tells me the perimeter of the larger is 45, and wants to know the perimeter of the smaller. So don't make the assumption that just because this one has a side of 3 and that's 9, that these have to be regular shapes. We don't know that. They didn't tell us that. So don't assume that unless they tell you. But I know the ratio of the sides. So this side is 3 and that side is 9, and those are corresponding. So my ratio here would be 3 to 9, and that was small to big. That is going to be equal to the ratio of my perimeters. So I know the larger perimeter is 45. That needs to go on the bottom because that's where I put the bigger side length. And this is the one I want, unknown. So cross multiply that, I would get 135 equals 9x. And divide both sides by 9. So you would get that x equals 15. So your perimeter here would be 15 centimeters. So perimeter, just use the ratio of the sides. Last but not least, for your review, here I know that my sides are in a ratio of 7 to 4. So 7 to 4 is big to small. So sides here, 7 to 4. Which means for area, I need to square those. So it would be 7 squared to 4 squared. Okay, remember area has square units. So it's a good way to remember what. So I'm going to set up my proportions. 7 squared over 4 squared equals, I want to know the bigger area. That's in the numerator. X over my smaller area, which is 16. And when you solve this, you're going to get x equals 49 feet squared. Okay, that is all I have prepped for you guys tonight. That was 45 minutes. Thank you for hanging out and watching. It's super awesome to see so many of you guys on here from all different teachers. Please send me any other questions. I'm going to stay on here for about 3 or 4 more minutes. And if nothing else, good luck on your tests. I will see you guys tomorrow. So have a good night. And until I get more questions, I'm just going to show you things on my desk. This is a turtle. There's not that much on my desk. These are stamps. This is Mr. Duranda's AAA card. If you ever need car support. That's about it. I have this pot holder. Miss Shantz gave that to me if you had her last year. Any other questions? Don't be afraid. Somebody else has the same question you do. Okay, rotations that run a point that is not the origin. So this is a tough one. This is a great question. So I'm going to create a little coordinate plane here. And let's say that I want to rotate this point, let's say 2, 1, around the point 4, 1, right? So let's say that's my center. So here's what I would do, and this is what a lot of your teachers I know have shown you to do. I usually draw in a new coordinate axis. So I would draw in a new x-axis that goes through my center, and a new y-axis that goes through my center. And now all of those rules that you guys know about rotations still apply. So all of those are still true. You can just use your properties, or what I like to do is make sure that we're kind of rotating here. So let's say we want to go 90 degrees clockwise. So if I take this and I rotate it 90 degrees clockwise around that point, it's going to wind up there. So I'm going to put this back for a second. Luckily, your loose leaf doesn't get unruly like this. Okay? And I know that if I rotate this, it's 2 to the left, so it will be 2 up. That would be a 90-degree rotation for this. Using my new coordinate axis, right? Just pretend that it's all the same. Okay? Then I'm going to look from my original origin, the real origin, and count there. So I would go over 1, 2, 3, 4. So this new coordinate would be 4, 1, 2, 3. 3. So my pre-image here might be A prime would be right there. So just draw in your new coordinate axis, rotate around that, and then count from your original origin. That was a good question. Katie, you asked before about rotating off a grid. We discussed that. Okay, I think I've hit everyone that I see so far. So, okay, rotate the object from a point off a grid. That's really hard for me to do without a compass. So here's what I'm going to do. I'm going to refer you to my teacher site, and I'm going to refer you to, there's a video on there of how to do like the 60-degree rotation. And if you guys go to my YouTube channel, which is where this is, you'll see the 60-degree rotation video there. So I would say if you want to see that, go to there. Segment and angle addition. So again, I have videos about those up on my YouTube channel. So if you want to see those, go see it. But segment addition, remember, you're talking about the fact that if you have this whole, it's made up of this part and this part, right? So A, B, C. Segment addition tells me that AB plus BC is equal to AC. Okay, that can be used in proofs. It can be used in just finding missing parts. Angle addition is very, very similar. Okay, so let's say this is A, B, C, D. Let's call all those points. Okay, angle addition would say that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. And again, you can use that in proofs if you know, let's say, the whole angle and you just want to figure out a piece of it, or if you know a piece and you want to put it together into a whole, that is a way to do that. So again, there's videos on my website for that, only because it's 9:30 and some of us got to go to bed. All right, last questions. If you can hear everybody dance now playing, Mr. Durand is watching The Office. He's turning it up and down now so you guys can hear it. Okay. All right. Well, thank you for tuning in. If you have other questions, find a math teacher in the morning. Your test is not until the afternoon. If you have other tests, good luck. And if you need me in the morning, I am proctoring. I'm actually teaching a class in the spa room, like the big spaceship room, until about 10. But I'm free from 10 until your test. And then I will come see you guys during your test. So I will see you guys tomorrow. Good luck tonight. Get a good night's sleep. Eat breakfast. Eat lunch. And I'll see you guys soon. All right. This video will be on my channel live if you want to rewatch it or send it to a friend. Have an awesome